We're going to learn how to use the picture project today. Find your zip file of the picture project and unzip it and open up that picture folder. You'll find several Java files. This is where the code is written, and the package.bluej file, that's the one that you'll open because that'll open the project in Bluej. So double click on the package.bluej to open it. Bluej is a learning IDE, integrated development environment. It was created by University of Kent and King's College London. So this is not what professionals use, but this is what students use to get the knowledge they need to become professional. Here it's loaded. You've got a picture project screen over here. There's a picture class, circle, square, triangle, rectangle, and a canvas. Right now, where there's a bunch of diagonal lines, that means that the code has not been compiled yet. So the computer has not checked and read your code to see if it's even valid. To compile the code, you can click on the compile button. Here everything was valid, it did not pop up any errors. You could also go to Tools, Compile, or select Command K to compile. The picture class, let's open it up. You can double click to open the class, or you can right click, go to Open Editor. What we see here at the beginning, this is what's called a comment. It starts with a slash and a star and ends with a star and a slash. Comments, those are lines of code. Actually, those are lines for human consumption only. They're not actually code. And this is ignored by the computer. So the first thing the computer actually sees is public class picture. The code in Java always is enclosed inside of a class. Other languages let you just run code without having to put it in anywhere. Java, everything's got to be inside of a class. So the class begins here with this open brace, and it ends at the bottom with the matching closing curly brace. Inside the class, we have methods. We can tell it's a class because it's green in Bluej. The methods are yellow. This method's name is main. This is the method that gets run when you execute the program. So what's happening in here? We have picture P equals new picture. So what this is saying is we have some kind of picture data type, and we're creating a variable called P that can only refer to pictures. It's a very specialized variable. Now, once we have this variable, we're going to create a new picture and store it inside the variable P. So stores the new picture with the variable P. So a new picture has been constructed. And now the next line, p.draw, we're saying the picture that P refers to, go draw yourself. So, hey P, find the picture that you refer to. Draw it. So draw belongs to the picture class because P is a picture. And since we're inside the class picture, that means the draw method must exist somewhere inside of the picture class. And if you scroll down, you can see it right here, public void draw. So this is the draw method that's being called over here. So what's happening inside? We have square wall equals new square. So the same format, picture P equals new picture, square wall equals new square. So we're creating a variable wall that can only refer to squares. We're making a new square and handing it to wall. And now we're saying, hey wall, set your y to 100. Hey wall, set your x to 60. So notice that we're saying which object we're referring to every single time before we call the method. Hey wall, change your size to 100. Hey wall, change your color to blue. And hey wall, make yourself visible. So this is repeated for all the different components of a picture. So let's see how we run this. Let's see what happens If I close this up, and since I edited something, I have to recompile it. And now I can right click and go to void main. Again, main is that method that we run to just start a program. So you click on main and just hit OK. Ignore what's in here. Hey, here's a picture. And we have our house, and our roof apparently is broken and terrible, so we should fix that. Okay, open up the picture class. Let's see, the roof. Since we name our variables well, we know which one refers to the roof. The roof is a triangle, and the roof is too low. So let's raise the roof and put it, instead of 90, like, how about 120? Let's try that. Now when I compile, Command K to compile there, it hides it, it makes it go away, so you have to rerun it. And our roof is worse. Okay, so that's not right. And here's why. The top left corner is your 0, 0. Okay, that's the key. The top right corner is 0, 0. And our y going down is positive. And our x going to the right also is positive. This is done so no matter what screen you have, the top left corner is always uniform no matter what size it is. Because if this screen, which it's 1,000 high, if I've got a laptop and up here we're like near 1,000, maybe my laptop doesn't have 1,000 pixels in height. So then this square will be off the top of the screen, which is weird. It makes more sense when you have more information that you can't see to scroll down than to scroll up. So the top left corner is always the 0, 0 points. Okay, so let's move the roof higher. Let's try 60, see if that works. That's close, but okay, you know, maybe if we just made this roof not as transparent, that would look good. So set transparency from 50 to 0. Cool, so now I got a solid roof. Now notice not all of them have set transparency, so the default for transparency for like this window and this wall, the default value is not transparent, but if you wanted to change it, you could go ahead and add a transparency value. We also can make a background color. Now if I want to make the background, let's make it nighttime. All these things are layered. I'm putting the wall first, and on top of the wall I drew this window, and actually that's not a window, that's a door. Let me change that to door. And I compile that and I get an error. The error here, well, I hover over it and it says cannot find simple variable window, because we haven't declared that a window exists. We said a door exists. So if you change the variable name here, you have to change everywhere else too. So you can do door, 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 or I can do Command F to find and replace. Find every window and replace it with a door. So let's do replace, 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 replace. And we're good. Okay, so looking at the picture again, we've got a wall is drawn first, then the door, then the roof, then the sun. If I want to make the sky or the background, I need to do that first. So the background, let's make it night. So I'm going to do square background equals new square. Now by default, it's going to be in the top left corner, but I'll go ahead and write it out anyway. Wall.set y0, wall.set x to 0. Oops, not wall, this is background. So background is set x0, background dot, let's make this big enough to fill the entire page, so change size 1,000, and background dot change the color to black. Finally, let's make it visible. So when I Command K to compile, I run the main method, and there we go, we've got the black sky. Now, if I want to make a moon appear instead of a sun, I could make another circle. But instead of the sun here, this is going to be the moon. Moon. And I want to scoot it over a little bit to the left so it'll overlap. So this will be 220 maybe I'll call it 230. And let's make this black. And now we have our moon because our two circles are overlapping and this circle blends in with the background. Last thing, if you want to make a custom color, we can go inside the canvas class, and up here there's the set foreground color method. We can just take one of these else if color equals something and then graph it as a color. We can take these two lines, copy and paste. And if I want to have a different color, like I can make Dodger blue. Dodger blue is 40 red, 144 green, and 255 blue. So I can Command K to compile there. And now if I want to make my house Dodger blue, I'll write Dodger the exact same way I wrote it there. I run it, and now I got my custom Dodger blue color. One other thing, to make more complicated pictures, you can actually rotate various things. So I can rotate this roof. Let's say there's a big windstorm. So I can do roof dot rotate 20. This is in degrees clockwise. I run it, and now it rotated it 20 degrees clockwise. If I want to go counterclockwise, what do you think I could do? Yep, -20. And there it is, rotated the other way. So that's how you can make your own picture. From here, you can make all sorts of shapes. You can make a car, you could make an elephant, a giraffe, whatever you want to do, just by combining these various shapes: squares, circles, rectangles, and triangles.